First of all, sorry for hitting you with ping pong balls. I had this, what I thought was a great idea, to build a robot that would shoot ping pong balls into the audience. And they're numbered so we can draw for door prizes. I have tickets to draw. Unfortunately, it only shoots a ping pong ball about 8 feet maybe at the most, so not very practical. This is it if you want to see it. This is minus the electronics that control it. It's made by a company called, well, the parts, that's what you get is just a box of parts, is from a company called MakeBlock. And you can find their stuff all over the web, I think Amazon for sure. And it's kind of a neat thing if you want to get into robotics. But that didn't work out so well. So my wife has just handed out ping pong balls, so hold on to them, we'll draw later. My talk, well, my whole quest to get involved in IoT began with Burke's talk last year. Was anybody here for Burke's talk? I think Burke, I don't know what his official title is, but he's sort of like the Red Hat Internet of Things evangelist, I guess would maybe be the best way to describe it. And my background, I'm actually an electrical engineer. I kind of got sucked into the software world. I tried to get out, but they kept pulling me back in. Well, I was digital focused, so don't ask me to design an amplifier for you. Today, the exact same combination of courses would be called a computer engineer. And so I had taken enough credits to get like a CS minor if we were allowed to have minors. For some reason, UAH didn't let engineers have minors, or we would all have a math minor for sure. So the first part of my career was part hardware design and part software design, but it was usually embedded software. And at that time, I kind of resisted software because it was all done in assembler language. This is late 70s, by the way. I'm old. And fortunately, in 1982, I was working for a company that had a co-op student from MIT, and he infected us all with a Unix bug. And so we all got interested in Unix, and of course we got interested in C, and we carried around our, gosh, I forget the name of the authors now, but the C, yeah, K&R, all right. Well, how could I forget that? So we all carried those around like a Bible. And that's when I first started to think, you know, software's maybe not all that bad. And I would guess by I had a period of time when I mostly did device drivers, which is still kind of close to the hardware. One of my last jobs of that sort was at Boeing. We built a thing called PCMAS, PCMAS, Portable Computer Maintenance Aid System. It plugged into the avionics bus of an F-16 and helped the flight technicians diagnose the plane, and they could pull up parts lists and schematics and crap like that. It was about the size of a small briefcase, which for 1984-85, that was small. If anybody remembers the original compact computers that were, you know, the first so-called portable computer, if you didn't mind lugging 2 or 3 bowling balls in your arm. Compact was about more like the size of what, maybe a Foot Locker? What would you compare it to? It's like bigger than a bread box. And so PCMAS was only about the size of a briefcase, maybe about 3 or 4 inches thick. And it was one of the first laptops to have a flat panel. It used to, I forget what that technology is called now, but had a flat panel, plasma display. But the coolest thing about it was it had to be gas tight, because there's fuel on the flight line, and you just can't have fuel vapors getting into where there's a fan with brushes sparking and setting everything on fire. And the other thing was it had to be able to be dropped on the tarmac, which is concrete, of course, from, I believe, 4 feet. Took us a while to get that one right. because even though it was rugged, it was all made out of aluminum. The insides would still get, slammed around, kind of like in a bomb blast where you might not be dismembered, but the shock wave, liquefies your organs. So by, I guess, 89 or 90, I had completely kind of migrated into the software world. And by 96, Java. And I've been doing some other languages like Scala and Groovy, but Java nonstop from 96 until now. But last year when I heard Bert talk, it was kind of like a light bulb went on, because I said, well, man, this is finally a chance to kind of get back to my roots and get involved in hardware. And IoT probably is one of the main areas where you actually do get to actually play around with hardware, which is what all this crap is here. How many engineers are in the audience? Raise your hand. If you're an industrial engineer, put your hand down. Everybody knows IE stands for imaginary engineering. So, so anyway, I am actually an electrical engineer. So I don't mind calling myself a software engineer, because I actually did run the gauntlet and pass awful courses like thermodynamics and a lot of stuff that I don't even want to think about. So that's sort of what got me started down this path. So let's get into it. The illustration here, that kind of sums up the Internet of Things in a very powerful graphic way, because, look at all the different crap that's connected to the cloud. That's exactly what Internet of Things is. It's the global set of devices with internet connectivity. So what are devices? We're usually referring to devices that are not being currently manipulated by a human. In other words, not, you're not sitting there with a mouse and a display and all doing, the typical interaction that we think of with computers. I say human specifically because I've seen some really cool do-it-yourself projects. One throws tennis balls for his dog, unassisted. He can leave, and the dog has been trained to bring the tennis ball back and drop it in the trough. I think it's got maybe 3 balls, so that it throws one while he's coming back or something like that. And there's another one that you can actually buy this kit on the internet that lets you dispense treats to your pet, like your cat or dog, and you can actually see it. You can see the pet on your phone. I think you have to buy your own tablet, but it can let the pet see you. The pet can definitely hear you. So I still would count that as Internet of Things, even though it's biological, but there's not a human. And so primarily what all these devices are about is gathering data, which for engineers is sensors, and controlling real-world entities. For us, that's generally called actuators or controllers. And that usually means something like turning on a switch, closing a relay, controlling a servo so that it actually, moves physically, or electric, like a stepper motor, to make something move physically, lock your door, open your garage door, those sort of things. That's what I mean by actuators. So what does it represent? If you think about, it's going to be at least an order of magnitude increase in the number of connected devices. If you currently consider connected devices as your laptop, your PC, maybe your phone, maybe you might have a tablet. So you might have 4 per person, but a lot of people maybe don't have a computer at home, or a lot of people don't have a tablet. But everybody has a front door, a back door, lamps in their house, lights that you want to turn on and off. You've probably got a refrigerator that you might want to monitor. You definitely probably have a thermostat that you might want to monitor. And you might want to monitor the usage of all the resources in your house, like electricity, water, gas. So when you think of all the possibilities, for every person, there might be 10 or 20 additional devices for that person. So that's where I get the figure of order of magnitude, although I've seen that in projections in a lot of different places in magazines. But we're thinking like a fan out of, instead of every person having maybe 2 devices, now there might be 20 in their house that gets fed back into feeding data somewhere over the internet. It's big money. Well, there's the device projection. 41 billion devices by 2020. I think there's only about 7 billion people in the world. So, that's 6 per person on average, maybe. Almost 6 per person. Cisco's predicting this market will be worth 14.4 trillion. Yes, I mean trillion with a T. That's not a typo. By 2020. Now, Cisco's in the business of selling this stuff, so I think they tend to exaggerate a little bit. But I've seen pretty big numbers. And here, this last bullet, IT Insights, which is kind of a market research, IT-oriented market research firm, they're predicting industrial IoT. IoT, by the way, have I not already explained that? Internet of Things is the typical abbreviation. I don't know why the O is not capitalized, but it's usually not. Anyway, they're predicting industrial IoT to increase from 4.1 billion last year to 13.5 billion by 2020. And that's just industrial IoT. And as you're going to see in a minute, I kind of break it down into 5 or 6 I'll have to count the bullets, but 5 or 6 different market segments. Industrial IoT is just one of them. So that's a lot of money. Not in military standards, but 13.5 billion is we'd spend 13.5 billion on spare parts for the F-35, but for IoT to actually make the country run better, 13.5 billion by 2020, that's a lot of money. So what's the impact of IoT? You're going to have more accommodating dwellings, your house, your office, more things will be connected. Typically on the IoT projects I've worked on, the back end, which most of you are probably familiar with working with things like Spark and Hadoop and databases that can scale to massive proportions like Cassandra. That's what's going on the back end. That's why these devices are on the internet in the first place, is so that information can be reported. And so one of the projects that I worked on, it actually learned your preferences, but it also learned the characteristics of your house, so that it could determine, for instance, if your house is at 70 degrees and we kick off the heat pump or the cooling, how long is it going to take your house to drift up or down so many degrees if the ambient temperature is a certain temperature outside? And it learns that over time, basically doing typical analytical stuff with tools like Hadoop, I guess. And I'll explain later why that's important to utility companies, but so it can kind of learn, when do I need to kick on your heat pump, let's say your air conditioning, so that when you come home at 5:30, it is nice and perfect, 70 or whatever temperature you like it. More accommodating also in the sense that, I'm not talking about Jetsons type modern, but more of the devices in your home are going to know your preferences, they're going to learn your preferences, and you'll be able to control, and they'll be able to communicate with each other. We'll talk a little bit later about the fog computing. These devices can talk to each other. Maybe your thermostat's talking to, I don't know, your front door lock. Maybe is the door open? More efficient use of resources. That's for one thing. Mainly energy. No secret that energy is in a shortage. And if you can, for instance, waste less of your energy each day, keeping your house warm when nobody's there, or keeping your hot water hot when you're going to sleep and you're not going to take a shower for maybe 8 more hours, then that's a benefit from you on the bottom line, how much it costs you, but also a benefit for the country. More efficient operation of businesses. I can't even begin to count all the ways that businesses can benefit. But one just obvious thing that I've noticed, have you ever been driving through an office park and it's raining and yet the sprinklers are just churning out water, and then you go home and then you read about, Atlanta, big water shortage, you're supposed to be watering every other day or whatever. And you're thinking, why the heck are you watering when it's, raining cats and dogs? I'll show you a sensor later that could help you if you're smart, if your house was smart, or at least your sprinkler system was smart. It could determine, has it rained within the last so many hours? No point in watering. Also things like office lights, turning them off when nobody's there. And we do a lot of those things already today. It's just that it's kind of ad hoc, piecemeal. All this stuff's not interconnected. Greater security. The project I'm working on right now, one of the things that they do is it's basically among other things, it can detect intrusions or fire. But rather than paying somebody like Ackerman whatever they charge per month, this thing calls you on your, or it texts you on your phone, and then there's an app, and you can go in and find out who just walked in my front door, or oh my God, my house is on fire. Please, Lord. More bacon. Just joking about that one. I don't know. More efficient slaughterhouses maybe, or farms. Could result in more bacon. If you are one of my Facebook friends, you get this. About 50% of my wall is post about bacon. I love it. What's the impact on us? In your little narcissistic, self-centered world, what is the impact on you as a software developer? We'll look at the growth that's being projected. IoT-related services to grow to 120 billion by, that's supposed to say 2018, not 20-18. Sorry about that. More devices to be programmed. Now that's embedded, so most of you, I'm guessing, probably don't do embedded programming. Although there are some, low-end devices that actually run Java. It's just not as common. More services to develop. That's where you guys will come into play, because it's that back end collecting all that data, or out at the edge or in the fog will be smarter devices that probably are running Java and are maybe, in addition to operating as a gateway for your house, maybe they're also making some some decisions based on consolidated data from all these devices that it has. So bottom line, more jobs for developers. We're not going to be automated out of our job, I don't think. I actually don't feel like, other than robotics, I really don't think IoT is going to have a negative impact on anybody's jobs. We're not going to probably have the fry thing at McDonald's on the internet. Who knows? So these are, it is 6. These are the market sectors, and these are not hard set. It's just kind of how I organize things. Government, industrial, infrastructure. By that I mean things like your utilities, like your gas pipelines, or your electric power, or your water. Residential, home automation. We've already talked a little bit about that. Retail and transportation. So I'm going to look a little bit at each one of these. Government, could we have online elections? After this year, I wish we could. There was a thing on, I don't forget what news channel it was last night, about most voting machines being used in 40 states are over 10 years old. And a lot of the voting machines that are out there, and I think this applies probably to the ones at least we use in Cobb. I don't know about the rest of Georgia. But there's, I don't think, like a real paper trail. They do print out a paper tally at the end of the night, but there's not a paper trail of every vote that was cast. I don't know why we can't do this, have online elections. I think we'd get so much higher voter participation. But I'm not holding my breath waiting for that one to happen. But your municipality might want to do things like engage in more targeted polling without having to hire a polling organization to find out, would you like more playgrounds built in your area? What other services would you like to see more of? Tourism support, this is kind of like beacons, which I'll talk a little more about later, or kiosks that, people could walk up to and get it. You're at one state park, you want to find out, well, what are the other state parks in the area? Or, we've been at the park all day, now we want pizza. Where can we get pizza? And then the last thing, trend detection. I mean, as we walk around with our devices, like our cell phones and whatever, almost everybody's got a phone on them these days. And I hate to think how much information they're tracking on us, but the municipality might not even have to poll. Like maybe they can just look at the data that's being collected by their back end and go, wow, this parking deck sure is popular. It's full almost every day. Maybe we need to build a bigger parking deck. Anybody that parks at North Springs after 9 o'clock in the morning knows what I'm talking about there. It's almost always full, packed. So that's what I mean basically by trend detection is without even having to take a poll, find out what would my constituents like to have more of and what would they like to have less of. Industrial, this is like manufacturing, better inventory tracking. That's a really big problem when you've got maybe 10 people working on an assembly line and they're sitting there doing nothing because the parts haven't gotten there yet. The Japanese have the just-in-time manufacturing. I don't think we've quite grasped that yet, but I've seen some organizations like there used to be a Chrysler plant in Huntsville, and they had I guess it was kind of like a automatically piloted like the things that haul you back and forth from the parking lot at Six Flags. What are those things called? I forget. Trams. It's like a tram, but it only holds parts, and it's automated. It follows a wire that's buried in the concrete to bring the parts from the warehouse over to whichever part of the factory it needs. So we'll be seeing more of that, and we'll be seeing more communication. But sometimes inventory is just lost. Like somebody was supposed to put it on this aisle, but they put it 3 aisles over. Where the heck is it? Because we're waiting. Tool tracking. This is mostly for businesses that have expensive tools. Now, I'm not really thinking by industrial, I don't mean like hospitals, but you think about some of the equipment that hospitals have that costs tens of thousands of dollars. You would like to make the most efficient use of that tool as possible, but where the heck is it? Mr. Jones is about to is having a heart attack. Where's the crash cart? You'd like to know that really soon, especially if you're Mr. Jones or his widow. Better production tracking, keeping track of things that you are building as they flow through the factory, to make sure that, like if it's a multi-step process, it's almost like a part tracking, that this partially completed product has gotten to the destination where it's going to be completely assembled. So where is it? Why isn't it here? What, I have 10 people waiting on it. Interconnected process controllers. I don't know if many of you know what that is. There are a lot of electronics in factories these days, but most of it, it's a market that's kind of sewn up. I can't really remember offhand the vendors that sell this stuff, but they're usually called programmable controllers. The problem is these things are just extremely primitive. I got a friend who's really involved in this market, and they are just now starting to get some machines that can say like run Linux. Prior to that, almost all of it is written in this proprietary control-oriented language. So it's I shudder even thinking about it. So more efficient use. Almost every one of these slides is probably going to mention this: more efficient use of resources. Um, Infrastructure. This is where I was talking about, like utility companies. Um, you take a utility company like I'm in Sawney, which is, if you live up in Alpharetta, you know what I'm talking about. It's a co-op. When I was in Cobb, it was Cobb EMC. Whatever your local power company is, they contract with guys like, or companies like TVA or Georgia Power or Alabama Power or whatever, to buy power. When they do that, they get a good deal on the amount of power that they say, we want this much power and we're going to pay for it. We're committed. We're going to pay for it whether we use it or lose it, you know. So if you contract to, like, say 2 gigawatts, or I don't know what measurements they use, but you're on the hook to use that even if there's no customer demand. So they would obviously like to push that number down. But on the other hand, when you hit peak and you go over the amount that you contracted for, you pay like 3 or 4 times the amount for that unit of electricity. So this is where load management comes in. Part of the reason we have peaks is because everybody comes home at 5:30 and damn, the house is hot, and they push the button to like cool this thing down right now. And one of the IoT projects I worked on, it was, well, actually it was funded by the Army, believe it or not. I can't remember the name of the big military base that's in on the border between Tennessee and Kentucky near Paducah. Fort Campbell, I think it is. But anyway, you know, a lot of these bases have 5,000 housing units on base if it's a really big base. And so they're keenly aware of how much they're paying for power, but they also made a perfect target audience, captive audience maybe would be a better way to put it, because the people living on base didn't have any choice in this. The Army said, you will do this. But in conjunction with the regional power company, they decided to attack this load issue, and they basically have smart thermostats. They have outdoor temperature sensors. They have they monitor some other loads. The refrigerator, I know, is one of them, if there's an electric water heater. But the big hitters in your household are you know, your HVAC system and your if you have an electrical hot water heater. So by gathering information from these smart thermostats, over time, as I was saying earlier, they figure out what are the characteristics of this house. And we know all these guys who work on first shift are going to come home about 5:30. How soon before 5:30 do I need to kick on the HVAC to either heat the house up or cool it down to whatever they want? And during the day, how low can I let it drop, or how high can I let it go in the summer without, you know, the risk of not being able to get it ramped back down? And if they can spread that load out, I don't know if you've ever noticed, does anybody ever notice their lights dim just a little bit when their compressor on their heat pump kicks on? That's because when an electric motor first turns on, it just sucks a huge amount of power. But a second later or 2 seconds later, it's dropped down to, you know, maybe a tenth or a fifth of what it was, that peak current. If you could just stagger these people so that if there were 20 houses on the block and you did like 0 seconds, 2 seconds, 4 seconds, whatever, you would accomplish a lot of load management just by staggering those times, and nobody would ever notice if their heat pump kicked on 4 seconds later than when they push the button. They don't immediately respond to you pushing the button anyway. Better. What?
That's coming from your local transformer, not from the grid. So I don't understand how it is drawing energy from the grid.
It's all coming from the grid. Your local transformer just steps the voltage down. It doesn't invent energy out of thin air. All your local transformer's doing is taking what's coming through your neighborhood, which is probably 440 volts, might be higher, steps it down to multi-phase 120, and then when you put two phases together, you get 240. So that's pretty much power in the United States. Better and faster leak detection. Is anybody interested in leak detection? Did anybody sit in a long line to get gas in the last couple of days? Because some stupid pipeline over in Shelby County, I don't know if you guys know where that is. It's Hoover, which is South Birmingham suburbs. This thing ruptured, and it ruptured going underneath a river, I believe. And so like I think that's the Cahaba River there. Anyway, that river is like, it's got all this gasoline. It's gasoline, not oil, floating on the top. So since it is gasoline, it is highly flammable. And I don't know, maybe it'll eventually evaporate or get washed downstream. I don't know. But who knows how much gasoline spilled out from the moment that leak occurred before somebody took action. All this could be automated. Turns out some of it is, but they're cooking the numbers. So one that I read about recently, does everyone know what a pig is? The thing that flows through the pipeline. I don't know why it's called a pig, but for some reason they call it a pig. It's basically, it looks like a giant version of those little cylinders that you use at the bank to send your money or your checks or whatever over to the teller. This thing's like a big version of that travels through the pipeline, and it detects things. It detects like cracks, weld failures, that sort of thing. But they also have at certain intervals along the pipeline pressure detection. So if they see a sudden depressurization on this segment of the pipeline, there's got to be a leak somewhere there. And so you need to shut it down here and there so that we can isolate that problem and not just let this stuff flow out. I'm kind of an environmentalist. I read that one single quart of motor oil, I think this might have been used motor oil, but anyway, one single quart of motor oil can make 250,000 gallons of fresh water not consumable by humans. So, one quart. And these pipeline people, I think they're not even required to report spills of less than 40 barrels. And I think there's 44 gallons in a barrel. So add up, multiply how many quarts that is, and you can imagine how many millions, hundreds of millions of gallons of fresh water are run by it. I think I've already mentioned connected smart meters, but it's basically tracking the usage of power, more efficient energy grids. This is probably what most of you are interested in, especially if you're interested in do-it-yourself stuff, which is what the last half of this is about. Things that you can automate within your house or automate or monitor. The project that I'm working on right now, if any of you are AT&T customers, you may have heard of something called Digital Life. It's a box that they put in your house that uses wireless. So, you don't have to worry about somebody cutting the cable. I guess they could still jam it. Nobody thought about that. But most of the things on this list, at least the first three, we can control. We have an app that you can say, is front door locked? And it'll come back and tell you audibly, yes or no. Or you can say, lock my front door, or open my garage door, I forgot my garage door opener. Those are the sort of things that you can do with it. And of course, as I mentioned earlier, it alerts you if there's intrusion or fire. You can turn your lights on and off. Did I forget to turn this light on? Or did I forget to turn this light off in my study? And it can tell you yes or no, it's still on. And you can tell it to shut it off. Who's ever gotten 100 miles down the road of their vacation and did I lock the front door? With this thing, you can actually say, is my front door locked? No, we'll lock it. And again, same thing, more efficient usage of resources. If you can waste less energy that affects your pocketbook. And in the long run, it affects the whole country, it affects the whole world. I got smart appliances. One of the things I mentioned earlier, they were monitoring refrigerators. But this is true of almost all equipment, anything probably that's got rotating parts. There are two indicators that something's about to go bad on you. Heat, higher than normal heat, or stronger than normal vibrations. And so if you can detect that, you can say, maybe it's time to replace this refrigerator, rather than, oh crap, my refrigerator just failed and now I've got all this food that's spoiled. So that's partly what we mean by smarter appliances. But your refrigerator could even report that while the temperature keeps dropping, the temperature keeps rising, somebody left the stupid door open. It could alert you over your phone, hey, you forgot to shut the refrigerator door. Maybe you just wanted to see the light. Retail, the main thing I think, they already do a lot of inventory management, and by inventory management, I mean detecting shoplifting. Most of you have probably noticed little things stapled to more expensive items. It used to be like a dongle that they would connect to it. These days, it's usually just a little bitty, what looks like a strip of foil with some swirly patterns. That's a RFID tag, radio frequency ID. And they've gotten so cheap now. I just read where, I forget the name of the company. Oh, Alien Technologies. What a weird name. Sold something like 4 billion of these things to the company that makes Gillette, razor blade. Apparently, a lot of people like to steal razor blades. So for like 10 cents I think it was 10 cents a piece, they could add this tag to their razor blades. And I don't know if you've bought razor blades lately, they're not cheap. And so if you can keep people from walking out the door with these things. But I think probably the biggest expansion that you're going to see is this thing called beacons. Everybody know what beacons are? It's basically a thing that you walk by and it detects, either probably your cell phone, that you're there. And thanks to all this research that are, tracking your purchases that they do on Amazon and all these other places, you go, oh, hey, Mr. Phil, we got a special on bacon. Don't you want to come in and buy bacon? Of course, the answer is always yes. This might be the one that most of you would notice the most, is if you can improve traffic flow. This baggage is a biggie. I read recently how many hundreds of millions of dollars the airlines lose each year because of mishandled bags, because they usually have to pay to deliver them, or they have to pay you some money because they lost it and they never found it. Somebody over in Scottsboro, Alabama is going to unclaimed baggage and, hey, look at this laptop. But it costs the airlines a lot of money. It also costs us a lot of frustration, having to replace stuff, or our bags don't get there, and so we can't, we got to wear the same clothes and the same underwear for 2 or 3 days until they find it. A lot of times it's just because the bag either went on the wrong conveyor belt, or you made the plane, or it didn't. More likely, it's the bag made the plane, but you didn't. With these RFID tags, and actually this is a little more complicated than RFID. It's basically a little thing that's like a GPS tracking type device. They can know exactly where your bag is at any second. There's a thing called differential GPS. Anybody ever heard of that? The GPS that most of us use can tell us within, I think, a few meters, maybe, of where we are. But if you set up a reference point, then between that and the satellite, you can get that down to like a couple of centimeters. It's insane how accurate. And this is what surveyors use, because they have to be extremely accurate with surveys. So it can know exactly where your bag is, why is this bag on a plane going to Denver when you're going to Toronto? Or it can check at the last minute, you didn't make the plane, but your bag's on it. Have you ever noticed they'll have a ground hold while you hear a bunch of bump, bump, bump underneath the plane? If somebody checks a bag and doesn't get on the plane, that's an instant, terrorist alert right there. That's how, one of the ways that you would, if you didn't want to be a suicide bomber, if you just simply wanted to be a bomber, then one way to do that would be to somehow get that bag on the plane, but you're not on it. So they can tell right up to the last second, did this person scan his boarding pass? Yes or no? And if they didn't, where is this bag? And we don't have to go sorting through. You see those little containers that they put the bags in so that they can load it into the plane. You don't have to go searching through 5 or 10 of those. You can know exactly where it is and go pull it. So mostly, though, I think it is a safety issue, but mostly this is for like cutting down on the cost to the airlines for lost baggage. And when they lose your baggage, when they lose a couple $100 million a year, that's not coming out of the CEO's paycheck. It's not coming off the company's dividends paid to shareholders. We all pay for that. So it's really helping us. Same thing goes with packages. Where's my package? I ordered from Amazon. It was supposed to be 1-day delivery. I need it for a speech tonight. Why am I thinking about that? So your package isn't there. Why not? It's sitting at your neighbor's house. I mean, we can tell from, some kind of electronic tag that exactly where that thing is. Smarter connected vehicles. Most of your vehicles now are already using what you would consider a LAN, a local area network. Most of them use CAN, which the C doesn't stand for car, it stands for Control Area Network. And this is something that originated in industrial applications, but the automakers adopted it. Part of the reason they adopted it is it's very impervious to noise, and I mean like electromagnetic noise. Like the every time your spark plug fires, there's some noise, electromagnetic noise generated by that. So they're already using CAN. You can save a lot of money, for instance, if I could, instead of running a 14 gauge wire, 2 of them, maybe out to every little thing I want to control, like my high beams, my low beams, my turn signal lights, my running lights, all the things that you think about in your car that you can turn on and off. If rather than running this separate sets of cables to each one of those things, you could run a nice thick power cable out to certain distribution points, and then smartly over CAN turn like your headlights on, turn things off, that sort of thing. So it's a way basically to cut costs. Wiring harnesses are a really common failure point for automobiles, probably more than just about anything maybe except the actual engine itself. Engine and transmission. But man, if you get a Friday car, what is it they say? You don't want a Friday car or a Monday car. Friday car, they've already maybe started a few of these. Monday, they're hung over from a few of these. And I had a Pontiac Sunbird once that somebody put the wiring harness, most of the wiring harness, ran across the rough edge of the chassis, and then the plastic bits of the dash got smacked down on top of that. And so every time this car vibrated, and all cars vibrated, they shake, they flex, it was basically sawing through the insulation. And so it got to the point where I could not control the fan on my my air conditioner. I would get to Boeing and I would turn the engine off, the damn thing would still be running. And I would actually have to go drive around And you know those little reflectors that they put in the middle of the road? Hit as many of those as I could to shake my car so that the damn fan would go off. And doesn't it suck to have to go in and explain to your boss, oh, I was late because my fan wouldn't go off? Who believes that, right? But if you had like a 4 or 8 gauge cable carrying 12 volts and it shorted, believe me, you would know about that in a hurry. You would probably either see the smoke or at the very least it would blow a fuse. And so you would know that right off the bat. And smarter electronics would be able to probably diagnose themselves. But that's all. A lot of that stuff's already in cars. What I'm talking about here, smarter connected vehicles, is what if your car, with its very accurate GPS, and the car up ahead of you, who just slammed on his brakes with his very accurate GPS, were talking to each other, you know, in a non-invasive kind of way. But basically, I'm here, you're here, oh God, the gap is narrowing at a very fast rate. Beep, beep, slam on the brakes or whatever. Now, somebody has a car now that will brake automatically, I forget which company that is. But this could facilitate that kind of thing. But it could also, going back to government and the municipalities, it could help them gather information on how many people are going down 400, how many of them are getting off at the Lennox Road exit, how many of them are continuing onto the connector, and base their decisions maybe on that rather than which contractor gave me money the last time I ran for election. Some of the things we're building around here I don't understand. So anyway, more efficient vehicles, more efficient use of your time. If you spend less time, you know, sitting in traffic or whatever, you know, that's wasting your time, or waiting for the tow truck after you hit that guy in front. So IoT communications, I mean, that's really what it's all about, is devices communicating with each other. Now, there's a lot of communication going on, not just to the internet. So the first category, and I'm not really going to talk about it much because you all know about, you know, a lot of these devices are already talking TCP/IP protocol over either a wired network or a wireless network. So assume we all know what that's all about. And that's the long haul anyway. You know, most of these other things that I'm going to talk about are either within your home or your building or maybe even within one chassis. So you've got low-speed wireless, that's Zigbee and XBee. Those both are very common in like the home automation market. There are a couple of others. We use one called Z-Wave. Z-Wave does anybody remember X10? These little things you could put in your house to automate switches, and they kind of sucked because I think they sent their data over the power line, which, you know, it sort of works, but like it won't make it through a transformer. You might not know this, but you know, 220 volt lines come into your house out of phase, and together you use both of those to like really power hungry things like your HVAC and your electric water heater, that sort of thing, your clothes dryer. And the thing is, about half of the things in your house that are just 120, the typical 2-prong, are 3-prong. These guys, if you're talking about the 3-prong with the ground, half of those things, and it's really not exactly half, because it's pretty much however your electrician felt like wiring this baby up. But some of them are on one of those phases and some of them are on the other phase. And the only real way those things can talk to each other, this is why your X10 probably didn't work, is it's got to go all the way back to the transformer to have a path. Trouble is, transformers to AC signals look a lot like inductors. And what are inductors very good at? Blocking AC signals. So it's hard to get. It's not a big deal when you're talking about 60 hertz, but when you're talking about kilohertz, it becomes a big problem. So Z-Wave, XBee, and Zigbee, these are all basically infinitely better solutions than your X10 box. I don't know if you wasted as much money on that as I did, but I got a bunch of crap invested in that. Everybody already knows about Bluetooth, I'm sure. Near field communications, is everybody familiar with this? It's like you tap. That's one of the things. Usually you have to, well, like the my Jag, a lot of you probably have one of these for your car. It just knows when I'm close to my car, because I could push on this button all I want to, and it's not going to open unless I'm like within a few feet of my car. But most of the time, it already knows I'm there and just lets me pull the handle and the door just opens. I hope that's how it works. I hope nobody else is. But it is actually, it's pretty smart, because when we have two of these, of course, and when the battery was dead in one, we were kind of sharing it. And we would get somewhere, and because we were sharing it, a lot of times I would sit it on the console or in the ashtray, which we neither smoke, so it's clean. And I put it in, and then get out and go to walk into the restaurant, hit the button. I typically don't use this to lock. I usually push the little button on my door, and it'll go beep, beep, beep. It's telling me, dumbass, you left this in your car. It will also do things like if I open the trunk remotely, but then I try to close it, I haven't locked the car. It will warn me about that kind of thing as well. But this is most of the beacons that I was talking about earlier are either going to be, doing this near field or Bluetooth. Chassis level. Does everybody know what a chassis is? To the engineers, the chassis is the box. If you think about like the case of your home computer, that's what we call a chassis. So these two protocols they're mostly chips talking to other chips within your system, or boards talking to other boards. And then we already mentioned RFID, the little tags. Zigbee, this is low frequency. Now, you might not consider 900 megahertz low frequency. Compared to audio, no, it's not. But compared to, most everything in your house nowadays is probably in the 2.4 or the 5 gigabit range. And because the 900 megahertz cordless phones have almost completely died out, they reclaimed this bandwidth to use for Zigbee. Actually, for use by what's called a WPAN. Let's skip down to this next to last bullet. Zigbee is basically one of many implementations of IEEE 802.15.4. Most of you are probably familiar with 802.11. That's your Ethernet. 802, IEEE has a whole bunch of these standardization committees. I hope I'm not running out of time here. But Zigbee is one of those, and this particular standard, 15.4, is the what they call wireless personal area network. Now, personal doesn't literally mean on your person, but it can mean like your general vicinity, like your house, your office, some space that is only maybe controlled by you and your family. So low latency, basically that's just a fancy term for, I get a response back. If I send, beam me up, Scotty, to one of these devices, I get a very fast response. I'm not waiting a long time. Latency over like the real internet, you're talking about seconds sometimes, 10 or 20 milliseconds if you're got a good say like Xfinity or some pretty fast broadband. Low power, these things are a tiny fraction of the power that like your cell phone uses. Most everybody's cell phone, if you get 10 hours out of your battery, you're doing really well. Apple says this thing's supposed to do, I think 10 hours or something like that. Must be the apps that I run, but I don't know. I never get that kind of, especially if I'm running Waze. Did anybody use Waze? When I'm running Waze, man, it just sucks the juice. And I can't even make it from here to Huntsville, which is only about a 3.5-hour drive, without probably 2/3 of the way there, I'm out of juice because Waze is just using so much power. By low power here, we're talking about devices that might run years on a little coin, the little coin lithium batteries. It might run months or even years on one of those. So we're talking extremely low power here, like less than a milliamp. Motorola, who's now Freescale, who's now NXP, they used to go around the country demonstrating this little microprocessor they had it was one of the first that was made out of CMOS. And they actually had a lemon with a couple of electrodes shoved into it that they powered this little thing, their demonstration unit, with a lemon. So low power to this industry doesn't mean what most of us think of in terms of low power. Low power to a lot of you is like, oh, my hairdryer is 800 watts instead of 1200. Low computing resource requirements. Most of the things that are running Zigbee, you don't measure RAM in gigabytes. You don't even, most of the time, measure it in megabytes. A lot of the little microcontrollers, and you're going to see some tonight, you're lucky if you have like maybe 256K of flash and 16K of static RAM that your program can use. So it's designed to be compatible with that level. Bad thing about Zigbee, it's not open. You can use it in your own do-it-yourself stuff, but if you want to use it commercially, like you want to incorporate it into a product, I'm not even sure you could get away with like using a whole bunch of this, say like in your factory. You have to join this Zigbee Alliance, you got to pay some money, then you get a say. If you don't do that, you get no say. It's not like the Java thing where you can sort of have a say. If they decide to zig instead of zag, or zig instead of zag, you got no vote on it. XB, very similar, probably because the same company, Digi International, is who originated both of these, but they gave Zigbee to this alliance, and XB is kind of like theirs, but it's open. Very similar to Zigbee, runs in the same spectrum, but it's more open, which is cool, but that also means it's more fragmented. If you look up XB on Wikipedia, there's this spreadsheet of all the different flavors of XB. And it's like, usually, you hope your spreadsheet fits on your width of your window, but this thing's like scroll, scroll, scroll. And it's like 40 columns, I think. And that's because everybody and their brother is out there building XB stuff. Now, I think you still have to maybe buy the radio chip from Digi International, but other than that, you can do your own thing. And also, these are pretty low-level protocols. You can actually talk to the radio chips with like a UART. Anybody remember UARTs? Yeah, you can actually talk to it with a UART, or you can talk to it with like a couple of other protocols we're talking about later. So you are really you can control it right down at the low level of sending ones and zeros. So for these reasons, it's more friendly towards the do-it-yourself community. You'll see this DIY frequently in the rest of the presentation. That's what it means, do-it-yourself. This is one of the inter-chassis or protocols. It's called I2C, inter-integrated circuit. So it's basically chips talking to chips. It's incorporated in almost every microprocessor that's out there today. It simplifies I/O expansion. It used to be if you wanted an 8-bit parallel printer port, you needed at least 8 pins on your chip dedicated to that. You probably needed more like 10 or 12 because of all the extra handshaking signals to just send that 8 bits of data. What I2C, it's a serial protocol. It runs over, in addition to power and ground, it runs over 2 wires. There's a clock line and a data line. So that simplifies expansion because you can run an I2C peripherals, and it can be a string of peripherals over 2 pins on your microprocessor. So that leads to lower pin count chips. If you've looked at the chips inside your computer nowadays, gosh, I was recently looking at one chip. It had 1,800 pins on it. It's just insane. It's a really highly integrated chip. It's not common, but even the Core 7 and the Xeon chips that are going into your PCs are in the, close to 1,000, I think. Actually, no, it's like about 1,300 because there's a socket named after that. I2C is bus oriented. I mentioned that you can string a bunch of peripherals off of it. I2C works more like a communication protocol, kind of like Ethernet, say, where there are all these things hanging off of it, and you can address them. You say, I'm talking to you now I'm talking to you. That's its strength, but it's also its weakness because all these things are talking to each other, it has to slow down some in order for things to respond. I think usually it slows down to like the slowest device on your bus. So you might have a really fast processor, but you expect a really slow, some A to D converter or something like that. You're going to slow down to that slowest link. SPI is a competitor. They're very similar, except for SPI is much simpler. It's also incorporated in most microprocessors. It's also, most of the things about it are just like I2C. The big differences are it's not bus oriented. It's 3 pins because there's a clock, and you can also have data in and data out. Some of you, if you're playing with Arduino, you'll see things labeled MOSI. I forget what the acronyms are, but it's data going in, data going out. And so once it's going every clock tick, it can be sending out a bit of data, but also taking in a bit of data. So as a result of that, there's no addressing. If you want to talk to multiple things, you got to figure out your own way of enabling this one and disabling that one. But because of that, it runs very fast. And among other things, you'll see SPI dominates the market for high-speed analog to digital converters because it can just shovel so much more data in and out than I2C can. Any of you, if you're playing with Arduino and even Raspberry Pi, you need to get to know these two protocols, I2C and SPI, because you'll see them everywhere. Most of these sensors up here hang off of one of those two. And Arduino and Raspberry Pi, I think they actually have both, so you can choose. So this is what I really want to talk about, hour and a half into the thing. Doing this stuff yourself. If you want to play around with Arduino or Raspberry Pi or whatever, how many people have already bought or own a board like a Raspberry Pi or one of its variations? Oh, quite a few. How about Arduino? Many Arduino people? Oh, a lot of us. Okay. So among other things, you can automate your home. We've already talked about all the reasons why. I recently bought a kit. It came from some company in the UK. It was like, I don't know, it was $25 maybe. It wasn't very expensive. And it was kind of like all the pieces of a starter kit for automating your house. It's got like one of the little things for doing intrusion detection and all these other little sensors. So, and it's got software loaded on a little micro SD card, which you shove into your Raspberry Pi, and you're in business. Because it's got like a GUI. It's Linux, and it's got a GUI, and so it's cool. And maybe you just want to have fun with electronics. Maybe you want to inspire your children to get into either electronics or programming, so they don't live off of you for the rest of your life like somebody I know. I actually kind of enjoy talking to kids who are, just suck this stuff up like a sponge, because that's what's going to keep us from crumbling like the Roman Empire. Or you can build a robot to fetch beer. You thought I was kidding. The same people who, actually with the very same kit, I could have built a beer caddy. This thing will actually fetch you. I don't know how the beer gets into the thing. Probably somebody at the other end has to load the beer, I'm guessing. But this thing will bring your beer back to you. There's dozens and dozens of these little silly things like this ball launcher out there where, I wish I'd have brought the box. Make Block, the one I bought is called the Ultimate Robot Kit. And there's like 20 things that they say you can make out of it. but there's, hundreds of people out there posting their own ideas about. And some of these, like the beer thing, started out as some guy out there came up with it, and then MakeBlock just adapted it. So, do-it-yourself computer boards. You basically got really two main categories. Microcontrollers, that would be like Arduino. Single board computers, that would be like your Raspberry Pi. Most of you will never run into this, but they're field programmable gate arrays. This is when you've got like really, really hard real-time requirements. Like some of these boards, like Arduino, you can, if some of the ARM chips that are on them have enough RAM, you can actually load up a little real-time operating system on it. Now, it ain't nothing like Linux, and there's no file system, and there's no X Windows server or any of that crap. But what there is a very tightly designed kernel that can give you response times in like the milliseconds, 1 or 2 milliseconds. You'd be lucky if you could guarantee 20 or more out of like a Raspberry Pi. But what if you need less than a millisecond? Like you need microseconds or even nanoseconds. Then you got to come out with a field programmable gate array. And you can actually get these and experiment with them. And I think one of the things I'm going to show you later is some guys built a synthesizer board out of one of these field programmable gate arrays. Now, it sits on top of an Arduino, which controls it, but the thing that's actually generating the sound is this one little field programmable gate array. And then hybrids are mixtures of these two. Now, one that I've got, and I'll pass around later, is called Parallella. And it's this chip called Zynq, Z-Y-N-Q, that a company called Xilinx makes it. Xilinx and Altera are the two big hitters in the field programmable gate array market. This thing is like half FPGA and half ordinary ARM. They've used the ARM core. And so it'll run Linux on that, but it can interface to this field programmable gate array that can just give you incredible real-time response to things. Microcontrollers. What I mean when I say a microcontroller is, well, these are some examples. Coldfire is what used to be, it kind of grew out of the 68,000. Anybody remember 68,000? Hotmail AT-Mega, it's kind of similar. It's a very RISC-like instruction set. You're probably all familiar with ARM. A lot of you probably think, when you think PowerPC, you probably think like the Power Macs. But that's just one arm of the development of the PowerPC architecture. And for every Mac that ever ran PowerPC, there were probably 10 or 20 industrial. They run Power, not PowerPC, I think. But PowerPC, the embedded PowerPC market is primarily cell phone-based towers, communication switching, the guts that actually makes your internet work. A lot of that's actually running on PowerPC. They've mostly got limited memory resources, I think I mentioned already, very low amount of memory. Some like the original Arduino, like maybe 8K of memory. Most of us never even bother to think about 8K, and it might have 32K of flash. You probably couldn't even load the Grub bootloader of Linux in 32K, right? So limited peripherals only in the sense that these are not the kind of chips that have like Ethernet ports or an onboard graphics or any of that kind of stuff. Mostly it's these SPI and I2C that we've been talking about. Now, I say limited, but they do have a lot of things on the chip like A to D converters and D to A converters that you might use to like measure sensor values or generate sound or something like that. So you will find that where you usually won't find those on like the chips using a Raspberry Pi. They're dirt cheap. If you priced Arduinos lately, good Lord, you can get an Arduino these days for a couple of bucks. And then Arduino is kind of like the exemplar of this. Oh, and if there's any OS, it's going to be an RTOS, not something like Linux. So the other category, single board computers, I'm thinking most of these are based on SoC, system on a chip. If you look at like Raspberry Pi, there's really only 3 big chips. That one I think is mostly doing like signal conditioning and power management for the USB ports and Ethernet. And I don't remember what the heck that thing on, but the one that's got the heatsink on it, that's a Broadcom, what's called a system on a chip. And that basically means they've used, since they're not having to do silly things like emulate the 8086 instruction set, because they're using like an ARM architecture or RISC architecture, they got all these, millions of transistors left over to do cool things like put Ethernet controllers and a complete graphics accelerator and all the circuitry to drive, HDMI or something like that on the one chip. Oh, and also like USB ports. Even couple have I think this is the only one that has SATA. Some of them claim to have SATA, but they really have this USB to SATA chip on there. It's what you find in those cheap little USB cases that you can take like a laptop hard drive and stick it into this, and now you got a portable USB drive. Has anybody ever broken any speed records with one of those? There's a reason why. Beware of any of these guys that claim they do SATA. Even this one only does SATA 2, which is not bad, but lots of memory. The Broadcom chip that's used on the Raspberry Pi, it's actually got memory on the chip itself. There's no external RAM chips. Now, lots. When I say lots, I don't mean lots compared to your Xeon workstation that might have 16 gig. The largest I've seen, the QV board has 2 gig. Not a lot of memory. But Linux is such an efficient operating system, and you'll find a lot of what I mean by headless? A lot of server-oriented Linux distributions that no X Windows, no GUI, none of that stuff. If all you're building is like some sort of a server, that's all you need. And then you SSH into it, or whatever. So most of these usually run Linux or, some variation of Linux, or Windows if you absolutely have to. Don't tell anybody if you do. Raspberry Pi is the exemplar. No Windows fans here, are there? You? Leave now. Okay, so Arduino I already mentioned. Inexpensive. There's a bunch of different configurations, and I'll pass some of these around later, but the smallest one is called Nano, Arduino Nano. It's not much bigger than it's about the size of my thumb, actually. Now that's a little bit deceiving because a lot of these things that say they don't take up very much space, like this little thing here, have anybody seen a Raspberry Pi Zero? The little green thing there, that's the Raspberry Pi Zero. But to use it, you need a mini or micro HDMI to regular HDMI converter, unless it's built into a cable. And you need a USB port because the Wi-Fi dongle, which is that little thing plugged in right there, only plugs into USB, and it's only got micro USB. But that's not the worst extreme. Can everybody see this little 1-inch cube right here? That's a Linux computer, believe it or not. It doesn't do much. Most of the real estate, by the way, is either air or the Ethernet connector. The Ethernet connector probably is 60% of the total volume of this little thing. Okay. I think we already mentioned 18 mega. Arduino is very well supported. There's, in addition to the original core developers who came up with it, it's just gone everywhere. And part of the reason for that is it's open software, but it's also open hardware. Anybody heard of open hardware? These guys actually put out their specs, their schematics, the 3D models for their cases, and tell you how to print it yourself in a 3D printer. It's a very giving community. And man, when you don't give back, they shun you. It's unbelievable how, like, there's somebody that was selling the Raspberry Pi 3 for like twice what the Raspberry Pi group actually sells it for. And oh God, if you look at their Amazon reviews, man, you would have thought that they killed Santa Claus, because it's just like the hostility. And then you got some people coming, oh, don't be so hard on them. It's like, screw them. They charge $70 for a $35 board. So when I say well supported, Arduino comes with its own IDE. Come on, which I have already started here. Why am I not seeing it? Well, that sucks. Why is it not showing me anything? See, I started to bring another projector just for this reason. I don't know what it's doing. Well, crap, because it's not on my slides, but wonder if it's... Oh well, that bites. Because I had some pictures of some of these things to show you, but I probably would have run out of time anyway. All right, so I'm going to start passing around some things. First of all, if you want to start playing around with this stuff yourself, first of all, you got to decide, how do you want to do breadboarding? And if you don't like to solder, if you're not an electrical engineer, you might not know which end of the soldering iron to hold. Does everybody know which end to hold? Not the shiny part. The blue and yellow part. It has to be hot enough to melt tin, so you're talking quite a few hundred degrees. So if you don't want to solder, this is what's called a solderless breadboard. And the reason it's called that, if you can see all these little matrix of holes, you stick the pins of your parts into this chip. And you can't see it, but underneath here, each one of those rows, a row instead of a column, are all wired together. So you can make multiple connections. So I'm going to pass this around so everybody can see it. The two other things that are on here, that I put on here just for fun, you can plug in a ribbon cable here and plug it into your Raspberry Pi. Now this one's for Raspberry Pi 1, which wasn't even called 1, it was just called Raspberry Pi, which I don't remember the size of the connector, but I think it's 26 pins. There's a wider version of this for Raspberry Pi 2 and 3. And this thing down here at the bottom, you can either plug a USB port in it and generate 5 or 3.3 volt power to power up your goodies, or you can actually plug a wall transformer into it. So this is a wireless breadboard. Yeah.
Hardware is all great, right? Everything is fine. Now tell me, how do you connect it to Eclipse?
Well, if my slides were still working, which they're not. Well, the Arduino IDE looks very much like Eclipse. The biggest limitation I've noticed is that I've not found any way to single step through code. That kind of sucks. But there is an Arduino plugin for Eclipse. So you can use Eclipse. I think you can do all the things that you would do with ordinary Eclipse. I haven't really tried it yet. Yeah. I would imagine probably most of the heavy hitters in the IDE market probably have jumped on the Arduino bandwagon, because think of how many more seats they can sell if it's not free. But
Plug in a resistor to a breadboard. If you plug in a resistor to a breadboard, connect it to your whatever thing is, and then it's connected to your computer, I'm assuming. So if you change the resistor value, it would register on your IDE and say, oh yeah, it's now not 10 ohms, it's 20 ohms now.
no, not at that level. No. If that resistor happens to be hooked up to an analog to digital converter and it's measuring it, yeah, then maybe you can find that out. But no, it doesn't go down to like that level of hardware detail.
But what I'm trying to you gave good numbers, okay? 4 billion to 15 billion, whatever, by 2020. How do we monetize that in the Atlanta area as a possibility?
Well, you probably wouldn't monetize it if you mean like professionally with something like Arduino, but you'll learn from Arduino how to do embedded programming. And then, yeah, you can monetize that because there are a lot of people in town who actually build hardware, like maybe they make cash registers or point-of-sale terminals or things like that, where there is an element of embedded programming there, any kind of control. The thing that's passing around here now, it has one real flaw in the sense, well, two. One is it's kind of fragile because any part you got stuck in, it can easily get ripped out if you're not careful. But also, it's not obvious, but all those little built-in connections that are underneath, they're like antennas hanging off of your wires. So they absorb all kind of electromagnetic noise. So if you want to do something more permanent, then you need to learn how to solder, unfortunately. It's not that hard once you get the hang of it. And then you want to use a breadboard like these. Can you see the copper-colored thing on here? You actually stick your chips and your resistors and capacitors. You stick it into there, and then you flip it over and you solder the things. Now this thing is one-sided, meaning copper on one, nothing on the other. Pass it around. This one's two-sided. The only thing that really is important on a breadboard is it gives you better opportunities to anchor things down, because the solder, in addition to being connected, electronically connected, it's also mechanically securing your parts. So that's what that one is. Oh, this one, by the way, notice it's kind of like in 4 sections. Don't do this, but you can snap them apart, and that's pretty typical in because when you have these things, they're probably going to be made overseas. When you have these things made, they're not going to make this one little bitty. They're not going to gear up for that. They're going to make whole panels. They call it panelizing, and basically it's just repeating the same. It's basically a graphic, black and clear film, or the equivalent of it. And they're going to, if they like to work in, what? Oh crap! There's no way I can cover all this. All right. Anyway, they do. They're not in onesie twosie. They do lots of these things, and these two are prototyping boards specifically made. You notice the shape. That's the Arduino shape. They're made to be shields on an Arduino, so you can build your own shield. Mezzanine boards was one thing I want to talk about. Mezzanine board is what engineers call any kind of board that sits on another board. Might also call it a daughter board if the thing it's on top of is called a motherboard. But it's basically, like a mezzanine level in a hotel. It's usually not a full level up. It's like, so in the Arduino market, those are called shields. I guess because of the shape, they kind of look like a shield. In the Beagle board market, which kind of straddles the microcontroller and Raspberry Pi market, they're called capes. I think their graphic looks like Underdog or something, so they call it a cape. And in the Raspberry Pi market, they're typically called hats, because they do sit on top of things. So, man, I got a lot of things to pass around. So, damn. It's a good thing I didn't need this. In fact, I think it broke. Yeah, it did. I'll pass it around anyway. By the way, a lot of these cases, they're good for display. I wouldn't recommend them for real world. By their very nature, they limit ventilation. But they are clear. So this is a Raspberry Pi 3, this first one that's coming around. God, there's so many pies. There's orange pie, banana pie. I don't forget how many other pies. Basically, because it's open hardware, anybody that wants can clone it, add a few features. And that's what the banana pie guys did. They just added some features that they thought Raspberry Pi forgot and left out. I forgot to pass this one around. This is a Raspberry Pi Zero. Got its own little breadboard built into the case. It's kind of cool. Yep.
If you're interested in the Raspberry Pis, Micro Center is selling them 99 cents for one. If you want another one, it's going to cost you $10, but you can buy one for 99 cents. If you want to try this stuff and get into it, it's a cheap one.
Yeah, the zero.
Raspberry Pi Zero.
This is called Odroid. At least they came up with their own name. I think it's unique thing is it's an 8-core. It actually does have a little fan built in to keep the chip cool, because when you actually start, it's running Linux, and when you actually start doing some serious computing, it cranks this. You'll hear this little fan. It really cranks up. It's louder than my Mac laptop when it's going. And this one's called QB board. It's also called QB truck. There's about 5 different versions of QB board. This is 3. I lost interest in some of the later versions because they got rid of the SATA port. I kind of got interested in this one for 2 reasons. It had a real SATA port, and it had 2 gig of memory. Very few of these boards have 2 gig of memory. What I originally thought I was going to do was take 6 of these and stack. You notice how it's stackable? Take 6 of these and stack them together and build like a Cassandra cluster. And then it dawned on me, what's Cassandra and any of these other big memory software things going to do with a little old 2 gig of memory? So other than just as a mental exercise, building a cluster out of these, probably not the brightest move. Now I tell myself, after I spent a couple $100 on it, it's actually got a little, like a 2.5-inch drive like you would see in a laptop. So we'll pass it around. I think that's all of the...
Can you mention like some very basic application you do with this stuff, or like hello world?
I mostly play with them.
Well,
I'm an electrical engineer. I get off on computers just for the computer itself. I don't give a flip what it's running. But I'll pass around some sensors in a moment, and you'll see. That's a Pi 2, I think, Raspberry Pi 2.
It's not Java, but it is JavaScript. There's some really good Node.js modules for interfacing with Arduinos, and there's specifically a library called Johnny5. If you look up johnny5.io, that's a great starting point. It abstracts all of these interfaces, so you just turn on lights or move motors or read sensors, all those kind of things. That's one of the easiest ways to get started with this.
Interesting you mentioned that. This is the BeagleBoard. It's BeagleBoard Black, which is like the latest incarnation. They highly promote JavaScript programming. So this BeagleBoard, it's very similar to Raspberry Pi. Oh, one thing is you'll notice it's got 2 connectors going down the side. It's roughly got twice as many I/O pins as a Raspberry Pi 2 or 3. So.
Is anybody doing Go on Raspberry Pi? Since it's a compiled system.
All I'm going to do is convert my 7-inch monitor to a photo frame using Raspberry Pi.
Okay, the rest of the things I'm going to start passing around are Arduino. Arduino Uno, which is kind of the basic one. This is the bigger one. It's called Arduino Mega something. A lot of extra real estate, but you'll notice the chip inside here's got a lot more pins, and that enables a lot more I/O. So the connectors have all been the very lower set. The set that's closest to the power connector. This is a subset that's Arduino compatible, and then all this extra stuff is extra stuff. And this is their latest one called Do, and it's just got a lot of extra features as well. Okay, so the next thing I want to pass around are, before I get off that one is Do. I don't need to pass that one. This green one here is the one I talked about, Parallella. You'll notice on the back, wait a minute. right one? Actually, no. Oh, this is Pine 64. I participated in their Kickstart campaign. And the interesting thing about it is a 64-bit ARM, so it can run 64-bit Linux, although they don't have ported yet, but it will eventually run 64-bit Linux. And it's also one of the only others that have 2 gig of memory. And then the last, I think that's probably all the single board computers. Oh, one more. This is the Nano I was talking about, the Arduino Nano, but the Nano is just this little bitty blue thing right here. The thing that it's plugged into and all the green stuff, that's just ways to break out all the signals so that you can actually connect individual wires into these green sockets. And then this red thing, it looks like a shield, but it's not a shield. The Nano actually plugs into it, and again, it just brings all the signals out. This is kind of one of the misleading things about Nano. They tell you, oh, it's just this thing about the size of your thumb. Yeah, it is. And if all you want to do is play with sketches, which is what they call programs, inside Arduino, it'll do it, you know. But the moment you want to interface to anything, doesn't help unless you buy something. So you wind up buying one of these things that's as big as an Arduino Uno anyway. So maybe the only place where this kind of makes sense to me is if you're going to plug it into some other bigger board that you're already building. Like you're going to plug it into one of these breadboards that are passing around. So that's Arduino Nano. Okay. I'm just going to start. Hate to dump all. What?
x86 architecture?
No.
Original. What is their construct?
Arduino, or which one are you talking about? Arduino is 8.
Boards, any of the plug and plays?
I don't really know how to answer that. These are capes for BeagleBoard. Actually, one thing that's kind of interesting about this one that's got the little blue connectors, this is for talking to CAN bus I mentioned earlier in industrial and automotive. And CAN bus usually runs over shielded twisted pair. And so that's why it's got a place to hook up, like the individual wires. This little shield here is kind of funny. It's basically, does it look like a game controller? You can't see it. This little black thing is actually the knob that plugs onto here, but it wouldn't fit in the box. So just imagine the knob being on there. So you got a joystick and you got 4 buttons, and you can make your own games, I guess, if you want to. And then the one that's sitting beside it, this is the synthesizer board I was talking about earlier. Does anybody know what a Yamaha DX7 is? Yeah. You do? You do? One of the first synthesizers on the market to use a highly integrated chip that implemented what's called frequency modulation synthesis. And so the DX7 was the first to use that. And if you've ever heard Van Halen's song Jump, that's the synthesizer parts, like the solo, all that was done on a DX7. Well, a DX7, it's like this long. Of course, a lot of that's keyboard. But even when the DX7 was boiled down to a rack mount module, it was still like a 1U module, a pretty good size. This little red guy right here is equivalent roughly to a DX7, except there's no keyboard, and you need to plug this on top of an Arduino to control it, because all it pretty much does is the synthesis. And they actually have a pretty rich little like a sound editor where you can come up with your own patches. DX7.
You can get a DX7 simulator on Mac.
Yeah. Oh, yeah, synthesizer. Yeah, you can. What you can do nowadays in processors running at 2 gigahertz with incredible floating point units, yeah, you can kick a DX7's butt. But what year did they do that? 1984. So, you got to take that into perspective. It's like, man, these guys are doing this in 1984. It's pretty cool. So a lot these are all analog, and these are mostly, well, this one's for logging, but this one is for motor control. One thing you need to be careful about with these Arduinos, when you start hooking up to relays or electric motors or solenoids, is these things take a lot of juice compared to what a micro can source. So usually you're going to need some kind of level translator or buffer, and that's what this thing is for. Because if you don't, first of all, it's just not going to work, because Arduino cannot sync enough current to turn a relay, most relays on. So you need something like that. These that I'm passing around that have, just like you see a lot of little grids of 3x3 or 3x4. These are for hooking up to sensors. They refer to these as groves. So your sensors are on little cables, so it's kind of like trees in a grove, I guess is what that's supposed to be. That's for the Arduino, the small one, and this is for the Mega. I'm not going to come through all of these.
Since we're getting down to the wire, does anyone have any more questions to ask her? IoT in general, or?
Yeah, if you need to go, don't worry about it. I'm not going to be offended. Interesting thing about these, this thing is called a Pi-Arduino. There's similar things called a Pi-Arduino. Basically, this is, you'll notice it's got the connector for plugging into Raspberry Pi here. But what's on top looks like an Arduino. So basically, you can take your Raspberry Pi and you can plug in Arduino shields on it. That other thing is a sound output. Raspberry Pis have sound, Arduinos don't. These are communications. That one's an Ethernet shield, and that one's a CAN bus. These things that have this little funny shield-shaped thing, these are the ones that talk XBee, the XBee wireless protocol I mentioned earlier.